We have seen how to create functions, how to pass arguments, how to process the arguments, and how to return the values. But these are the functions which has a name, parameters, and a huge body which can go from more than two lines. But there are special form of functions which we are going to study now are called as a lambda expression. So what is a lambda expression? A lambda expression are nothing but the anonymous functions or the functions without a name. But why will you need a function without a name? So these are really handy when you are working to like writing a quick functions which are not needed later on, or something like you are working on the higher order functions. The higher order functions are the functions where you are passing a function as a parameter to some other functions. So we will study about the higher order functions in the advanced concepts. Here we are going to see how to create the lambda expressions. So now let's see the example. So as an example, let's define a square function whose parameter is a number and it returns the square of a number. That's it. And when we call this function by passing a number, let's say I create a variable, give it value 4, and then I use print square and I pass this number to it. Let's execute this program. Python lambda expressions.py, and the output is 16. Obviously 4 square is 16. Now let's see how can we represent the same square function using a lambda. So the same function, if we have to define as a lambda expression, what we can do is, let's say we create a variable sqr equal to, we use the keyword lambda and then the parameter, let's say number colon number to the power 2. That's it. This is my lambda expression. Now if I have to call this, I'll just give a simple print statement and call this square and pass number to it. So it is as simple as that. Now let's execute this. So let me first give a proper message so that we can identify using square function. This one is using lambda expression. Using lambda expression. So let's run our example. See, both have returned the same result 16, so it works properly. Now let's compare the syntax. So in these two functions, if you see here, we have defined a function using def keyword, the name of the function, parameters, and then we defined a single return statement, a return value. If we compare the same function with lambda expression, we see that we defined an expression lambda, then we have one kind of a parameter which is similar to what we do here with the parenthesis, and then colon which defines the body of this, and then this is a statement which will be evaluated, and this is kind of a return statement, and this entire lambda function is given to a variable. Now when I call this variable with the parenthesis and pass a number to it, it automatically executes this lambda by considering this number as a parameter and executes this entire operation. So the lambda expressions are used when we have to create an anonymous function which are really simple one. We cannot use it in complex situations. But here you can see that I pass only one parameter. What if I have multiple parameters? Let's say we modify this function and we say the number and exponent. So basically exponent is the number which is basically the power value. So number to the power exponent, that is what we are trying to do. Now here, if I have to represent the same thing, I can do that with exponent, then exponent, and this will still work. Only thing is here I exponent equal to, let's say 2. Here then I'll be passing. Of course, your variable names can be different. I'm just using them for the simplicity, nothing else. Okay, now let's execute this. So let's execute that Python lambda expression, and the result is still same. Now here we can see that creating a lambda expression is a simple syntax with the lambda keyword, the parameters that we want to pass to the lambda expression and the actual expression. And it is a simple expression which you can write in one line, and hence you can use it in the simple cases, not in the complex situations.